All right. So lesson 5. Um, did you have any questions on the part 1? Or part 2? I kind of did them all, and I understood them. I didn't really have any problems.
Yeah, some of the stuff's still kind of iffy for me, but I got through it, so I don't have any questions thus far.
Awesome. So let's just do the Q plots at the bottom since it says we need to do them together. Um, so like if the Q plots are in like a straight line, I think that's normal. But then if they like have like an S shape to them or um aren't, then I think they're not normal. Does that make sense?
Yeah, exactly.
So I think just make sure. Okay, so I think A is not normal because it like starts off like this and then goes up. You see that?
Yeah, I do.
And then B also is not normal. Um, so C, I was kind of confused about because I thought it was not normal, but then I looked in the book and it is normal because even though it like has like the snake look, since it's like in equal like distances or whatever distributions, I guess that makes it normal. So if it goes in the S form, um then it's okay as long as it's in normal in distribution.
Yeah,
Um, D is normal because that's pretty much a straight line. Um, E is not normal. It's
it's not. Is
and
F
then
normal?
F is normal. Yeah.
Okay, all right. E is kind of iffy for me. I'm like, but yeah, yeah.
Yeah.
Like everything else seems like, yeah, I get it.
I think I'm pretty sure it's normal. Or I mean, I'm pretty sure it's not normal.
Oh yeah, I just looked up. I'm opening up the answer key, and yeah, it's
Oh,
yeah, you got them all right.
all right, cool. All
Perfect.
right. So let's do this thing. Okay. All right. True and true.
The total area under a dense curve must equal.
One. Pretty sure.
Yeah. Under certain circumstances, a density curve can drop below the x-axis.
I think that's
Axis. False.
I think so because I think it has to.
I've never seen the graph fall below an x-axis. Like I'm trying to like remember all in high school
Yeah.
and stuff, and I don't. It's not supposed to
Where did I
for
see?
this distribution. I don't know.
I don't think
A
it does.
density curve. Yeah, I don't remember exactly what that is either.
Normal density curve. Okay, I have that right here. Um, where'd it go?
Yeah,
Oh, sorry. The normal density curve is symmetric and bell shaped. Yep.
yeah.
Okay. Use the following image to answer question 6 and 7. Which of the following elements of the figure represent the z-score in this image?
What is? I forgot what the Z core is.
I think it's the
It's the normal distribution, like the standard score.
yeah. Okay, so like on in the book, there's a graph and it's like shows the number, the little box on the bottom on the left, the negative one on the quiz. It shows that as it's saying that is the z-score. So I don't know if that's A, B, or it's not A, B, or C. I think it's none because there should be one pointing to that, I think.
Or it might be. I'm trying to like look it up. I mean, it could it be
Okay,
B?
yeah. Oh, so okay, so it's C.
It's C?
I think it's C because let's see if I can show you. I don't know if I can show you. Do you see that?
Yeah.
Okay, so it's showing right here. Oops. Oh, it's showing right there. The score next to both of those squares. So that right, that says in that yellow it says Z score on both of the squares. So I think it would be C.
Okay.
Does that make sense?
I think so, yeah.
I think. Okay, we'll just go with that. Which of the following elements of the figure represents the probability that the random variable z will be greater than 1? Isn't that B?
Yeah. That's definitely B.
I think it's B.
Oh, C?
As B, like boy. B.
Okay, yeah. I was like, wait, what? Okay.
Yeah.
According to um, the percent rule, what proportion of data from a bell-shaped distribution would be within one standard deviation of the mean?
Okay. Within 1, it's 68.
60.
I think 68% of the data will lie within 1 standard deviation of the mean. 95 is 2, and 99 is 3.
Perfect.
So it's 60. Suppose random variable z has a standard normal distribution. Use the normal applet to answer this question. What what proportion of the values for this random variable will be between -1 and 1? If your answer is a decimal accurate to 3 decimal places. What? What's the normal applet?
I have no clue.
Normal applet?
I thought at first it had the normal apple. I'm like, okay, well, I have an Apple phone.
Okay, I got it. Okay. So the normal probability applet is a visualization program offering statistics students blah blah blah. Okay. You can find this applet on the main page. Oh. Oh, okay. I have it up. It's like a little program thingy that popped up. So standard normal. Oh, I have no idea what this is.
I have no idea.
Suppose random variable z has a standard normal distribution. Use the normal applet. Okay. To use the applet, follow these instructions. Click on the area below the curved line to shade in the unshaded region. Okay. Click and drag the red lines to adjust the scores. That's where they need to be. Type a z-score into one of the bottom input boxes and hit enter to get the right area. But what z-score do we put in? That's what I'm not getting.
Yeah, because I was thinking it has something to do with the chart above, but the chart above said answers 6 through 7. That's it.
Yeah.
So I'm like, where do we get our numbers from?
Supposed to. Okay, well, what's a standard? Let me see if I can find it. If there's like a. Is there like a standard Z number, like a normal distribution number? There is? I didn't know about that. Because it's,
Yeah, I didn't know that there was a standard number either.
yeah, for normal. I'm supposed to put right there in the area the normal distribution, standard normal distribution of the Z number, whatever that is. That's how you use it. Yeah, they can like move, but they said to have it right here. Oh.
You might get this if you can hear it. What are you doing?
All right, I think it's point,
Not really.
so 0.317.
2.317.
0.317.
Okay.
According to the tablet thingy.
Yeah, I never saw where the normal applet was.
Okay, so now I just change this.
No. Okay.
Oh,
Okay, I've seen this many times, but I still get a kick out of it.
well, no, because they want. So it's that. All right, just kidding. So I think it's 683. So 0.683.
0.683.
I think so. Okay, so then the second one, I'll just move these to 2. Okay. So then that one, the number 10, excuse me, I think it's 0.955.
Okay.
I hope these are right. Negative 3.000. So then 11 is 0.997.
Okay, so it says look carefully at your answers to the last 3 questions. What did you observe? Would it be A? That it goes from the 68, 95, 99 rule?
Oh. Yeah.
Oh, wait. Yeah, those are all the answers. Yeah, so, okay, so that's A. So I think we did it right. Yeah.
Okay.
Fast food.
Okay, so it says,
Oh, go ahead.
Okay. The amount of protein that an individual must consume is different for every person. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the populations of the United States. The protein requirement is given in terms of the number of grams of food quality protein that must be consumed each day per kilogram body weight. The population mean protein requires for adults is and and the population standard deviation is uses information to answer questions 14 through 17.
Awesome. Okay. What proportion of the population have the protein requirement that is less than? Okay. The amount of protein requirement is given in terms of the number of grams of quality. The population mean protein requirement for adults and population standard deviation is that. So I don't know how to figure these things out.
Well, I think we can just ignore the numbers and symbols because it's like the same. Oh no, it's not. Standard deviation's -1, -1. It has reciprocity. Oh my gosh.
That's not gonna work. I'm sorry, not you. I'm kidding.
Okay.
So that's it.
This is your moon.
Yeah.
Line, which is one of these is one standard deviation.
Okay.
So, what's your mean?
So the mean is 0.66.
Okay. So 0.66, standard deviation is 0.06.
So I
So
moved
6,
this.
6 is in the middle. No,
That's not. Maybe still have
that's normal. You can't change these -1, -2.
Yeah,
Okay, change it to 0.07.
this one. Negative
Point.
0.07. What portion of the population have a protein requirement that is less than?
Oh. No, go back to the 1, 1.
The one. Oh. Negative 1.0. Okay. Alright, which one?
You're looking for 1:1.
Fall in your bed.
A little bit outside.
about some.
So, choose points.
Please, where did you plug that?
No, it's 0.0.
Facebook.
Oh, the mean. Yeah.
And you want to know if it's less than 60.
Yeah, what proportion of population?
Facebook.
Well, good. Okay.
0.59. Not with it. 0.6. So everything is in.
So do I just change this to?
Smart.
That's not all of them.
actually shared it.
Mm-hmm.
You're gonna see if you can see it, but you can't.
Just post one privately, please.
No, you. It's
I'm still slowly doing
Sorry, we're trying to figure it out.
Oh yeah.
Like I don't remember reading anything about this. I don't think there's anything in the homework about this.
Yeah, exactly. I'm about to put unicorn for my answer.
Yes.
Figure it out.
Yeah. I'm like, it'll equal a unicorn because this is unbelievably hard.
Okay.
You just use a calculator.
Okay.
So you have to put. So
This.
you're going only down by 0.6 instead of 0.7.
You might be able to see it now. Since it tags you in
Into the top or right here. So negative 0.857.
Now, on that area. It's less than.
That's the probability. Okay. So 13.
13.
Yeah. 13 is 0.196.
Okay.
Okay, so what proportion of the population have a protein requirement that is more?
it. Probably with this one group of people.
Yeah. Okay. That one's it. Okay. So 14 is 0.804.
Yeah, exactly.
Yeah, because it's just to make it equal 1.
Yeah. Okay. What portion of the population have a protein requirement that is less than 0.70? So we have to do
So you're 6 3
negative. What? Yeah. Right, this one too?
because you're on the top half.
Oh, okay.
Yes. 0.6.
Yeah.
Oh, okay. So 15 is that. Okay, so 15 is 0.716.
Okay.
How long did you read that?
I had to read it a second
Okay,
time.
find the probability that a randomly selected person will have a protein requirement that is between 0.6 and 0.7. Hint, remember that to find the area between two values, shade to the left of each Z zone you calculate and then subtract the smaller area from the larger area. Make sure your answer is positive. The probability that is randomly selected observed will lie between two values. Give your answer a decimal accurate to 3 decimal places.
Okay.
None.
And here's mine.
Three.
Taylor's thing that
How okay, so you have the answer.
Yeah.
So you have this one right here. You have the area of people on the left side.
Yeah.
Okay. Then you also have the people
On the
on the total other side.
yeah.
Then you have the people
Okay.
Mm,
Fine.
okay, well, let's use this number.
Okay.
So do 1 minus 9.
Like on a figure.
Sure.
1 minus 0.760.
So this here.
Okay.
We're looking for one between, right?
Yeah, between 0.6 and 0.7.
Okay. And you have the answer from below, right?
Yes, that one.
So what it represents the number is
0.28.
Now what's the number on this side?
0.196. Okay, so then just add those.
So now you add those and subtract the number. So 1 minus 0.196 minus
196 equals minus
52% of the people.
are in between 60. Okay, give your answer the decimal. So 0.52. Alright, 16 we think is 0.52.
0.052.
Should I put a 0 on it? Here's that
0.
weird. Want to see that?
Yeah. It was saying to like, so it's 0.052, right? That's how you enter it in. Yeah, it was 0.
0.520.
Oh, okay.
16. I think because it says give your answer as the decimal accurate to 3 places.
Should we put it in the before?
Yeah, then that's, yeah, that's why he used that verbiage.
And
Is that one on the far right? That has a people of what?
No.
No.
No, that was,
sorry, Timmy.
that was,
Oh, no, you're,
Okay, so then how do we find the 35th and the 80th?
yeah. Okay?
35th percentile.
For the protein requirement.
He is, character. And think of, Don Coltrane,
Mm-hmm.
kind of like that, but not as extreme. Has the same thing along with Helen. One of my companions is now married, or getting married or something.
I thought you meant,
Hell is the one with that blanket, right?
It'll be three.
just kidding.
No.
I said, are you?
No.